Example 2. A dietitian wishes to see if a person's cholesterol level will lower if the diet is supplemented by a certain mineral. 7 subjects were pre-tested and they took the mineral supplement for a 6-week period. Test the dietitian's claim at the alpha equals 0.05 level of significance. Perform a 95% confidence interval for the mean difference in cholesterol levels as well. The results are as follows. Notice that we have a before and after test, and the subjects are paired with the before and after results. So these samples are dependent. And we also have the assumption that the population is normal and there are no outliers according to the box plot, so we don't have to check any of the conditions. We want to test the claim that the cholesterol level will be lower if the diet supplemented by a certain mineral is taken. So let's let group 1 be the before, and we'll let group 2 be the after group. Then we can look at the claim. The claim is the before group will have more cholesterol than after you take it. Your cholesterol level will be lower after you take the mineral. So we're saying the mean of the first group is greater than the mean of the second group. A lot of students think the symbol should be less than because it says lower, but remember, the before group should have more cholesterol, and then after you take the supplement, it should be lower. So make sure the symbol is in the correct position, greater than, and that's why it's important to let the reader know which one's group 1 and which one's group 2. The complement is the opposite of the claim, and the opposite is mu1 is less than or equal to mu2. In step 1, we're going to state the null hypothesis and the alternative hypothesis. Like always, the null hypothesis is always the one with the equal sign. So we're going to say mu1 is less than or equal to mu2. For the alternative hypothesis, we have mu1 is greater than mu2. Now, again, there is a difference in notation from the textbook. From the textbook, they'll say the mean difference is equal to 0 for the null hypothesis. They always use an equal symbol for the null hypothesis. For the alternative hypothesis, they're going to say the mean difference is greater than 0. So again, be aware that there is different notation for the null and alternative, but they mean the same thing. Step 2, we'll state alpha. Alpha is equivalent to 0.05. Step 3 and 4, we're going to go to Statcrunch. Let's try the problem on Statcrunch now. I have the before and after results of the cholesterol levels. And we're going to go to Stat, T-Stat, paired. Group 1 is the before and group 2 is the after group. We're going to scroll down and we are going to do a hypothesis test, and let's make sure the null hypothesis is set at equal 0. Do not change that one. And for the alternative hypothesis, we're going to say greater than. Let's click compute. And here is our test statistic. Our t-statistic is 1.764 and our p-value is 0.0641. From Statcrunch, we have our t-statistic is equivalent to 1.764, and also from Statcrunch we have the p-value is equal to 0.0641. For step 5, we are going to ask, is the p-value less than alpha? Is 0.0641 less than 0.05? And of course, the p-value is not less than alpha. So we do not reject the null hypothesis. There is not enough evidence to conclude HA. Now, in this case, recall HA was mu1 was greater than mu2. The before group had higher cholesterol than the after group. So we're saying there is not enough evidence to conclude the cholesterol level of the before group is greater than after taking the mineral. Since the p-value is not less than alpha, we do not reject the null hypothesis. There is not enough evidence to conclude the cholesterol level of the before group is greater than after taking the mineral. You can have variation in your conclusion. You can also say there is not enough evidence to conclude the cholesterol level will be lower after taking the mineral supplement. And that's still saying HA in words. So just be aware you can have variation in your conclusion, but it'll still represent HA in words. Let's look at a 95% confidence interval for the problem. For that, we'll go to Statcrunch. Let's do a 95% confidence interval. We'll go to Stat, T-Stat, Paired, and I am going to select column 1 as the before group, and in the sample 2 we'll put after. So group 1 is the before group, group 2 is the after group, and now we're going to go and click confidence interval. Let's set that at 0.95. Let's compute, and here's our confidence interval. The lower limit is negative 6.03 and the upper limit is 37.17. From Statcrunch, we have the lower limit is negative 6.03 and the upper limit is 37.17. So remember, this represents the average difference between the pairs. And I'm going to ask the question, is there a 0 in the interval? And the answer to that is yes. There is a 0 in the interval because this number is negative and this number is positive. So when we take the difference between the pairs, we have the average is between a negative number and a positive number. So 95% of the time there is a 0 inside the interval, and that implies there is no difference, which makes it really easy for a conclusion. So we're going to write, we are 95% confident that there is no difference in the cholesterol levels. We are 95% confident that there is no difference in the cholesterol levels. Example 3. A sports fan often complains that referees show preferential treatment to the home team. Below are the number of free throws attempted by the home team and the away team in 13 randomly selected games. Using Statcrunch at the alpha equals 0.05 level of significance, test the claim that the home team shoots more free throws than the away team. We'll let group 1 be the home team, and we'll let group 2 be the away team. Now, these are a matched pair design because they are in the same game, so the samples are dependent. And now we'll have to check the conditions. I have entered the data values for the home team and the away team. Now I want to look at the QQ plot to check the conditions. I first have to go to stat, tstat, then paired. I will select group 1 as the home team and group 2 as the away team. And I want to click save the differences. So we're going to save the differences so we could do the QQ plot. Click compute, and we don't need this tab at the moment, so we'll close it. And you can see that there are differences given in the third column. Now we're going to look at the QQ plot for the differences. We'll go to graph and scroll down to QQ plot, and I want to click differences to make sure the differences is approximately normal. And here's our graph. It does look approximately normal. It is linear and therefore approximately normal. We'll check to make sure the differences has no outliers. So go to graph, box plot, click differences. Let's go and make sure we draw our boxes horizontally, and we'll press compute, and there are no outliers. So all of the conditions are met. We can try the problem. Now let's try the problem. We're going to look at the claim, and the claim is that the home team shoots more free throws than the away team. And of course our home team is group 1, so we're going to say mu1 is greater than mu2. And the complement is mu1 is less than or equal to mu2. For step 1, I'm going to state the null hypothesis and the alternative hypothesis. The null hypothesis is always the one with the equal symbol, so mu1 is less than or equal to mu2. The alternative hypothesis is mu1 is greater than mu2. And now we can do step 2. Step 2, alpha is equal to 0.05. And just a reminder, in the textbook and on Statcrunch, the notation is slightly different. For the first one, they'll say the mean difference is equal to 0. They always use an equal 0 for the null hypothesis. And for the second one, the textbook will use the mean difference is greater than 0. Okay, so just remember, in the textbook, they have different notation. In step 3 and in step 4, we are going to use Statcrunch. I have the home and away team in 2 separate columns, and we're going to go to stat, tstats, paired, and I'm going to select group 1 as the home, group 2 as the away, and we were doing a hypothesis test. Let's leave the null hypothesis the same, but we're going to change this to greater than, and let's press compute. And here is our test statistic. Our t-stat is 2.308, and our p-value is 0.0198. From Statcrunch, the t-statistic is 2.308, and from Statcrunch, the p-value is equal 0.0198. In step 5, I'm going to ask the same question that I always ask. Is the p-value less than alpha? Is 0.0198 less than 0.05? Yes, it is. So we do reject the null hypothesis. There is enough evidence to conclude And remember, our conclusion is always in terms of HA. Let's remind ourselves what HA was. It was the mean of the first group is greater than the mean of the second group. So we have to put this in words. We do reject the null hypothesis. There is enough evidence to conclude the home team shoots more free throws than the away team. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude the home team shoots more free throws than the away team.